Derivation from trigonometry, the SINE rule. Okay, so what's that? Let us start. Okay, how to prove that the SINE rule is derived, that we will see over here. Okay, what is the SINE rule? This is a properties of triangle. Okay, that for any triangle where A, B, C are the three sides of the triangle, then the ratio of the angles opposite to side A will be A, capital A. The and the angle opposite to side B will be capital B, and the angle opposite to side C will be capital C, right? And the ratio of A by sin A equal to B by sin B equal to C by sin C is equal to 2 by R. And this is the SINE rule. This is the SINE rule whose derivation we are going to see, and we will do it today. The SINE rule, right? Here, in any triangle, the sides are proportional to the sines of the opposite angles, right? This is the derivation, right? Now, so here, let the triangle ABC be any triangle, and just draw the circle through ABC having S as its center. Okay, so we can do, we will draw a triangle inside this circle. Okay, if this is the circle, right, and this is having center, let's say this is the center S, right, this is the center S. Now from here we will see that the triangle ABC, its radius is R. So radius of this circle is R. Radius of this circle is 2R, right? So let us do one thing. Just to draw the triangle, we'll take the sides A and B such that here you can see AB consists of two parts, 2 times the radius. Okay, this thing we need to take care, right? After this, BC will be the segment, and BC will be the segment, and ABC is that triangle, right? So here, joint C to S, this one, join C to S and produce it till it meet the circumference, let's say at a point D, right? Now connect B to D, this one, right? Now what we will see, that the angles BDC, this one, right, and angle BAC, this one, are equal, because these two angles are angle on the same segment. This is the segment, right, and these two angles are equal, right? So we can say that angle BDC, we can say that angle BDC, this one, is equal to this, that is angle A, isn't it? If these angles are equal, then we can say that, and also you can see DBC, DBC is an angle into the semicircle, because CD is the diameter, right? So the angle DBC, this angle is 90 degree, because this is angle into the semicircle, right? So this is 90 degree. Now here we can say that sine of this angle, sine of this angle A can be written as sine of this angle A. Why we have taken sine A? Because here we have sine A, right? So from here we can say that sine of angle A, right? Since A is equal to BDC, so we can say that sine of angle A will be equal to sine of angle BDC, because these two angles are equal. A is equal to angle BDC. Here we have already proved it. Angle onto into the same segment, on the same segment, right? So that's why sine A equal to sine angle BDC, right? So BDC, sine of BDC will be BC by DB, BC by CD, isn't it? BDC, sine of BDC is how much? This angle, this is the perpendicular, this BC is the perpendicular, right? And BD is the base and CD is the hypotenuse, right? So here, hi Roger, hi Ajit. So BDC can be written as, sine of BDC can be written as perpendicular, that is BC, divided by the hypotenuse, that is CD, right? Hi Roger, hello. So here sine A can be written as BC by CD. And what is BC? BC, this BC is nothing but side opposite to the angle A. So this is of length small a, isn't it? Right? So we can write sine of angle A, right? Sine of angle A is equal to BC by CD, but BC is equal to A. This is A. So that's why we can write it's A by CD. And what is CD? Here, from here to here, this is R, and S to D again R, right? So yes, you are right, Roger. Yeah, definitely you are speaking in Portuguese, so I am speaking in English, so not an issue, we can be connected, right? So this will be CD is equal to 2 times R, this R plus this R, right? So we can write as 2R, right? So we have proved sine A is equal to A by 2R, or we can write it as A by sine A. When sine A will be going to the denominator of RHS, this is equal to 2R, right? This is the same thing, you can see A by sine A equal to 2R. So one part is proved. As we proved for this A, similarly we can prove for B and C also. So in that case we can write sine B as B by 2R will prove similarly, and again we can write sine C equal to C by 2R, right? So from these three equations we can say that, from the second one we can say that B by sine B is equal to 2R, right? And from the third one we can write C by sine C is equal to 2R. So from here, if this is equation number 1, if this is equation number 2, and this is equation number 3, then when comparing the equations 1, 2 and 3, because all of these are equal to 2R, you can see 2R, 2R and 2R, right? So we can write by Or let me squeeze a little. So from here I can write from equation 1, 2 and 3, we can say that a by sine A, that is LHS of equation 1, is equal to b by sine B is equal to, that is LHS of equation 2, and from equation 3 this is equal to c by sine C. So in this way, and this all these three are equal to 2r, right? In this way we have proved the SINE rule, right? This is the SINE rule, and this is a very good questions are coming from using this SINE rule. Amazing, good job teacher. Hi Roger, thank you so much for your compliments. I like you, love you dear. Let's be connected. Yeah, nice to see you. Yeah, Beast Hunter, trigonometry, definitely you are right. Rule is theorem. Yes, yes, the SINE rule. This is the theorem which we have proved it now, right? So in this way we have solved this question, and you can use, we will see in the subsequent sessions, we will use the application of this SINE rule, right? Though through the playlist into my channel you can see few questions on SINE rule, because there are numerous questions on trigonometry, maybe more than 60-70 questions into that playlist, right? Right. Definitely, Roger. This is side by, because A, B, C. If this is the triangle, you can see the angle opposite to B. This is a small b. This is the length of AC, a small b, right? And if you can see, if this is angle C, you can see this is C, then the length of AB is C. This one is C, a small c, right? And these are A, B, C. That means if you, these are the three sides of that triangle. If this is A, this is C, and this is B, if we are comparing this one, this shaded triangle, right? Then this is opposite to angle C is C, opposite to angle C is C, this one. Opposite to angle B is AC, that is B, and opposite to angle A is BC, that is B, right? So these are, sorry, opposite to A is A, not B, sorry for that. So A, B, C, right? So these are these three, A, B and C, because these are the small ones, right? And these are the capitals A, B, C. These are the three angles A, B and C. Similarly, this is presented over here, right? So Roger, I think you understand it, and thank you Beast Hunter, thank you so much for watching. Let's be connected. Okay, I hope you like this today's session. So with this I want to conclude. Yeah Roger, triangulus incretio. Yep. So I think the explanation is very much understandable to you. Any doubt you can put up into the comment box, and love to see you all together into the session and coming up with separate and selected questions with the proofs, okay, with the theorems, and we will see the application of these questions. Okay, thank you so much for watching. Thank you dear, thank you so much. Take care. Bye bye. See you.